Okay. I don't know if I'm going to get to it today. I wanted to. It may be something I get to next week. You will be required to basically understand and learn the unit circle. You will not have to memorize every single point. I will show you how to do it in a way that you only have to memorize the first quadrant. I think the way I teach it is pretty good, so you can wait until I do. You don't have to go crazy because it is a lot if you think you have to memorize everything on it. Okay, so now let's look at a 45-45-90 triangle. And this is the proportions, but basically let me show you real quickly how you get it, because it's not that hard to get to it. Okay? So if I have a 90-degree triangle, a right triangle with two angles that are 45 and 45. Remember the last slide when we talked about triangles, if I have angles that are the same size, that means that the sides opposite are also the same size. Isn't that true? Okay, and remember that, so I'm assuming that all of you know the Pythagorean theorem, which says that a squared plus b squared equals c squared. This is only true for right triangles. So a being, I'll just say this, I'll make this a, I'll make this b, and I'll make this c. So now I can say x squared plus x squared equals c squared. 2x squared is equal to c squared. And again, x squared equals c squared over 2. So x is equal to the square root of c squared over 2, which is that's c squared, which is equal to c over the square root of 2, which is equal to, what did I do wrong? Why did I get the square root of 2x? It should be the square root of 2c over 2. Where did I go wrong here? Let's see. X squared, c squared over 2. X is equal to the square root of that. Did anybody see my mistake? What did I do? I can't hear you. Can you turn your mic up a little? There's a, up at the top where it's talk, there's a slider bar.
Yeah, I see it.
Oh, there you go. I can hear you better now.
So, shouldn't c have to equal the square root of 2?
Oh, I see what I did. Thank you. I got it. Never mind. You're right. I was solving for x instead of for c. Sorry about that. So, c, cancel that. C is equal to the square root of 2x squared, which is equal to the square root of 2 times x. Thank you very much. Who was that? So there we have
Savon.
Savon. Oh, hey, Savon.
Hi.
Thank you. Yeah, so C is equal to the square root of 2 times x. And so that's how that triangle comes into being. Okay? Now we have a 30, 60, 90 triangle. And this is a little different, so I'll show you how we can make this work. So we have basically, let's say we have, because we really don't know a lot about that triangle. So let's say we have an equilateral triangle where all these angles are 60 degrees, right? Well, if I bisect this angle, then on my, over here I have 30 degrees, and over here I have 30 degrees, right? And if all my sides are x, because it's an equilateral triangle, then when I cut it in half, this side becomes x over 2, and this side becomes x over 2. So far, so good? All right. Now, again, I could use my Pythagorean theorem. So let's call this height y. That means I have x squared, x over 2 squared, plus y squared is equal to x squared, right? That's my Pythagorean theorem. I'm going to use this value, and this value, because now I have a right triangle. So this becomes x squared over 4 plus y squared is equal to x squared. Y squared is equal to x squared minus x squared over 4, which is equal to 3x squared over 4, which is equal to the square root of 3. So that means, here, let me I'll do that. Hold on. Take one more line here. I'm trying to do too quickly. So now I have y, since y squared is equal to that, y is equal to the square root of 3x over 2, right? So that would mean that, well, let me draw this triangle again. Here, I'll draw it. I'll draw it up on the top here. So now I've said that this is x, this is 1/2 x, and this is the square root of 3 over 2x, right? How is that similar to this? Well, I'm just trying to show you how this equilateral triangle, I can go from this equilateral triangle and prove this triangle has those sides. Yeah, so the new triangle is everything divided by 2. So basically, because they're similar triangles, all the angles are the same. This is actually my 60-degree angle. This is 60 degrees, and this is my 30 degrees, right? Because that's the top angle is the angle I bisected. So if I multiply each, because they're similar triangles, I can multiply each side by 2, and I end up with the other triangle. Or I could divide the triangle that is given by 2, and I get the triangle that we have here. It's just that the triangle that I created is actually standing differently, right? Because I have 60 degrees here, and they have 30 degrees here. Who doesn't know what I just said? I know I'm going a little quick, trying to get a lot in. Okay, so where did I lose you? Here, let me do it again. Yeah, I'll just get a new page. So here we have an equilateral triangle. This is 60 degrees, this is 60 degrees, and this is 60 degrees, right? That's what an equilateral triangle is. Okay. So if all the angles are the same, that also means all the sides are the same, doesn't it? Okay, so we're there. Hold on a sec. Now, I'm trying to make a 30, 60, 90 triangle, right? And right now I have a 60, 60, 60 triangle. So what I'm going to do is I'm going to cut this angle exactly in half, because it's an equilateral triangle. If I drop a line right down the middle, this will become 30. This will become 30. And that also means that if this is x, this side here will be x over 2, and this side here would be x over 2, right? Okay, so far so good? All right, now, let me get a different color. I want to know what this height is. That's the only thing I don't know, right? Because if I just take, so let's do this. I'm going to erase the part of the triangle I'm not really interested in. So is that okay? This is the part of the triangle now that isn't really important to me anymore, because all I really care about is my 30, 60, 90 triangle. And we know these things are true about it. Okay? Okay. So now I can say, using my Pythagorean theorem, oops, I made it too large. So, sorry, if I say this is A, and I say this is B, and I say this is C, then I know that x over 2 squared plus y squared is equal to x squared. Isn't that true? Okay. And now I just solve. So I have y squared is equal to x squared minus x squared over 4, which is equal to 3x squared over 4. And that means that I'm going to take the square root of both sides, and I get the square root of 3 times x over 2. So that means now I know that this is equal to the square root of 3 times x over 2. This is equal to x, and this is equal to x over 2. Okay, so, Darla, I never teach memorization. If you memorize things, very often you will forget them. If you memorize things, so let me just say really quickly, the more you memorize, the worse you will do on tests, and you will probably fail your final exam. There's just too much information. There's just too much information. You've got to have some understanding along the way. I don't expect you to prove that that triangle is that. But I do want you to understand where it comes from. It's not just magical numbers. Okay? That's all. I am never going to ask you to prove this. Where did the 3 come in and stuff? Well, x squared minus x squared over 4. So in this course, maybe one of the reasons it's hard is it's all fractions. Your fractions have to be excellent. So I think that lends itself to having it be very difficult at the beginning for people whose algebra is not excellent and whose arithmetic is not excellent, because without a calculator and fractions, you're going to have to get it. Yeah. So you're going to have to... I'm gonna, like I said, I'm gonna skip a lot of steps. I'm gonna assume you know your algebra is good. That's my assumption here. So often I will skip steps. Okay, no problem. Okay, so that's that. So now, if we look at let's look at a circle. Okay, so I'm looking at a circle, and this is my x-axis, and this is my y-axis. And I'm always going to say that if I'm looking at angles on a circle, this is always going to be 0 degrees. Yeah, sure. By the way, so everybody can try this right now. If you want to save, so this is being recorded, but if you want to save slides, okay, so do it with me, and then you'll have it. You can go to File. Up in the upper part of the screen it says File, Save, and it'll say Whiteboard. And then what you can do is you can either save a selected page or you can save all the pages. Now you don't want to do it now, because if you do it now, what you'll be doing is saving a lot of empty pages. If you save it at the end, it will actually save everything I've written. If you don't like my handwriting, that won't help you that much. So you might want to save it now so you can fill it in yourself. But not necessarily print screen, but you can actually save the entire lecture, the entire whiteboard lecture with my notes in it, always. Okay, at the end. Or you can print screen.